Hi, we are the Byte team, and in this video we are going to present our results of MiniChallenge 7. Talking about this mini challenge in general terms, we must to develop a open loop controller. For this assignment, we need to do in three sections. First, we have to control a simulated robot with our open loop controller. Then we have to implement the same controller to the real robot in the Smack factory. And finally, we have to make a path generator for the user and implement it a custom path.
In this section, we're going to present how our project works, all instruction, initialization, and execution of our project through a launch file, which contains our nodes, libraries that we use, initialization of RVs, parameters, and all the necessary things to see our simulated robot and the process to control the real robot.
Now, the methodology follows. Starting create two nodes. The first node is to declare the point and selection of the points. Once we have the points, I have to make the math operations. Now, can the movement be done? If the answer is no, ask for other values and show that message to the user. On the other hand, if the answer is yes, send the first signal and make the movement and publish the velocity to the robot. Now, the node 2, get the velocity and the angle, then make the position control, math operations, and set a signal to node 1, I got the position. Have I finished making all the points? If the answer is not, increase the counter plus 1, so that it enters another conditional, repeating this process and increasing the counter until the object is met. When we finish all the points, the program is over, and the simulation is done in parallel using the launch files.
First of all, for this section, we are going to define what we expect of the challenge. Obviously, we expect the perfect following of the trajectory in the simulated and real robot. But during this project, we observe differences in the robot behaviors. The main reason why it's not the same behavior is because in the simulated robot, we don't have any perturbations in the trajectory, friction in the wheels, noise of the electronic components, and the implementation of the open loop control, where we only hope the robot reaches a specific position, but we don't have a feedback in the type of control. About this type of control, it has disadvantages and advantages. The most important advantage is that with an open loop, we can know better our physical system or robot, how much is far from the simulated reality. And on the other hand, the principal disadvantage is that we don't have feedback about our system. We trust that the robot will reach the path that we implemented in our path or controller communication. And when we talk about robotics, we must consider that we are working in three different realities: the simulated, the estimated, and the real one. Based on our experiments, we have identified two factors that are significantly influence the precision of a robot's movement related to its kinematics. The first one is the mass. Mass plays a crucial role as it affects the distance a robot can travel. It is essential to consider it in simulations because it directly impacts the robot weight and consequently its ability to measure and control force or torque during rotation. Ignoring the mass can lead to imprecise simulations, especially when we consider friction in the floor. The second point is the inertia. The rotation of robots induces inertia, presenting challenges at low speeds, as mentioned as is the first point. However, at high speeds, we can achieve greater precision because the motor gains more control over stopping and obviously it has residual movement. It is important to note that abrupt stops can potentially reduce the robot lifespan by damaging the motors. To ensure high precision in simulations like the ones we conducted in this challenge, it is crucial to calibrate the robot linear and angular movements, consider velocity, and the achievable distance without abrupt braking. And these results are supported by our experiments, where in the second translation experiment, the one of the 4 points, we observed significantly disturbances in the movement when a prior calibration was not performed. Due to the low speeds and the absence of consideration of the robot mass, we have a bad result in that simulation. In contrast, in the first simulation, we place greater emphasis on the calibration to achieve more precise movements because we want to have a better square.